Welcome to Algebra 1 Honors. This is going to be the format in which we are going to complete our guided notes for the course of the year. You'll be watching a video and listening to the audio track while completing your set of guided notes, following along and doing the examples, copying down definitions, reading through the web page to get some of those definitions or examples, and then completing 2 to 3 action problems each night before coming to class the next day and discussing those problems. So I just want to spend a few minutes talking a little bit about these video notes. We typically don't spend a whole lot of time going over definitions. You will learn those definitions by reading through the web page. You can see here each section of notes typically starts off with a terminology section. There's going to be new terms and definitions and some notation that goes along with those each section that we go through. And then we'll move into some example problems that I will model for you. Now, it's always helpful for you to have your graphing calculator along with you. I'll be walking you through some of those functions and key sequencing so that you know how to use that graphing calculator as well. And then you'll have a few problems to complete at the end of each section of notes. Those are called the action problems. You'll complete those action problems in your math notebook, and we will start off class the next day discussing those action problems. Now, as you go, there's times you're going to need to pause the video to kind of catch up and maybe even need to rewind and rewatch an example problem, and that's perfectly fine. Each one of these videos, we're shooting for about 8 to 12 minutes, no more than that. But if you pause and rewind, it should take you around 15 minutes to watch the videos. Obviously, you may have questions. Feel free to put a little star or question mark by the section of notes that was a little bit confusing to you, and make sure you ask those questions the following day in class. I'll be happy to clear that up with you. Also, keep in mind that we will be discussing these topics the next day in class, so our goal is to clear up any confusion that you might have from the notes. All right, with that, let's jump into section 1.1. The language of algebra, and a lot of this first unit is learning some of those basic algebraic terms and functions that are going to carry us throughout the course of this semester. So first of all, we got a bunch of definitions. Take a minute to copy those definitions down. You see over here on the right hand side we have some examples of variables, of algebraic expressions, and algebraic sentence with some verbs. So some math verbs here for us that we'll be looking at this year are the equals, greater than or equals, less than or equals, greater than, less than, and the not equals. Also an equation, what makes an equation different than an algebraic sentence, what makes it different than a formula, and also here is a formula. So take a second, maybe pause the video, copy down some of those missing blanks and those examples, and we'll move on. All right, here's another familiar term for you. Following the order of operations, we broke it down to this acronym PEMDAS. Please excuse my dear Aunt Sally, or perhaps you prefer this one, people eat McDonald's and suffer. It's just a clever way of remembering your order of operations and how to simplify an algebraic sentence or statement. So we're always going to perform our operations with parentheses first. Now, parentheses are really just a smaller part of what's known as grouping symbols. There are other grouping symbols such as the absolute value symbol. So if I gave you 6 minus 10 in the absolute value, you would have to evaluate that first. Another grouping symbol would be the square root, such as the square root of 25 minus 9. You would need to first evaluate 25 minus 9 and then take the square root of that difference. Other grouping symbols are the division bar. So for example, if I had 4 plus 2 all divided by 3, then I would first need to add my 4 and my 2 and then divide that sum by 3. So those are all just the grouping symbols, and that must be handled first. Next up is exponents, and we're always going to simplify our exponents and actually all of our operations moving across from left to right. Just like you would read a sentence in English, you're going to read a mathematical sentence from left to right. Then we move on to multiply and divide, and then add and subtract. Again, keeping our order from left to right. All right, let's take a look at example 1. It wants us to evaluate the expression. Notice that this is an expression, not an equation. to the nearest hundredth. Now, another piece of important topics here in mathematics is understanding your units and your place values. So we're going to round to the nearest hundredth, which would be our second decimal place. So we're going to evaluate this when A is 5, B is 9, and C is 4. We're going to start off by substituting our values into this expression, which says the opposite of B, so that's opposite of 9, plus the square root of B squared, so 9 squared, minus 4 times 5 times 4 again. All right, and this is all going to be divided by 2 times 5. So we have a couple of grouping symbols here, this fraction bar or this division bar, and we also have the radical. So we're going to start by doing the inmost grouping symbol first. That's our 9 squared minus 4 times 5 times 4 again. And that's going to simplify down to negative 9 plus the square root of 81 minus, now we're going to do left to right multiplication here. That's 4 times 5, which is 20, times another 4, which is 80, all divided by 2 times 5. We're going to simplify that to 10. All right, next up, we're going to simplify what's underneath our radical symbol, which is our square root, and that's 81 minus 80, which is going to simplify to 1. So that's negative 9 plus the square root of 1, all divided by 10. Well, the square root of 1 is 1, so this becomes negative 9 plus 1 all over 10, and that gives me negative 8 over 10. Now, when I want to simplify this to the nearest hundredth, then this comes out to be a negative, whoops, forgot my 0 here, negative 0.80. So there's our 2 decimal places. Now, do you need that first 0? No, you could have also written this as simply negative 0.80. So there's our first example using our order of operations, PEMDAS. Let's take a look at a few more examples here. We have evaluate 88 minus 16 divide by 2 times 3 to the 6 minus 4 power. Notice that 6 minus 4 are those smaller numbers in the superscript, so they're exponents. So we're actually going to handle our exponents first here. There's no other grouping symbols. 6 minus 4 is 2. So that gives me 88 minus 16 divided by 2 times 3 squared. Now 3 squared is 9. So I'm going to simplify that next. And now as you look across, we have a subtraction sign, a division, and a multiplication. So multiplying and dividing come before my subtraction and addition. So I need to do my 16 divided by 2 and then times that by 9 because I'm moving from left to right. So this gives me 88 minus 16 divided by 2 is 8. 8 times 9 is going to give me 72. So really I'm looking at 88 minus 72. And 88 minus 72 should result in 16. Next up, we have an absolute value symbol, which is, remember, is a grouping symbol, and then a square root, which again is a grouping symbol. So we're going to first evaluate what's inside here. This is the absolute value of 7 minus 16, which is negative 9. Subtract that from the square root of 25 minus 9, which is 16. So the absolute value always returns positive values. So this is 9 minus 4, which results in 5. All right, let's jump into a word problem because that's typically what we'll be doing in this course. We'll be taking a look and breaking down words and assigning them mathematical values and writing equations and sentences and formulas and functions and looking to evaluate those functions. Maria has 860 stamps in her collection. She plans to buy 20 stamps each month. We're going to write an algebraic sentence describing how many stamps she has after m months. So she's starting off with 860 and she's adding to that 20 stamps per month. Here is an algebraic sentence. Now it doesn't have a verb yet, so we're going to set it equal to the total number of stamps that she has. And we'll just call that T for total. Now we got our verb in there. Here's our algebraic sentence. We want to know how many stamps she's going to have after a year and a half. Now I'm going to circle that. And this is just a good problem-solving strategy. just to underline some of those important variables and key indicators that they're looking for in the equation or the problem. And I'm going to circle that because a year and a half is a different units here. We're not going to put in 1.5 here. We're actually going to put in the number of months that are in 1.5 years. We know there's 12 years in a month, so add half more to that, and that gives us 18. So now we're going to evaluate 860 plus 20 times 18, and that will give us our total number of stamps. So 860 plus our 20 times 18 should give us 360 more, and that's going to give us 1220 for the total number of stamps. All right, one more example here for us today. And this is example 4 that talks about the height in feet a ball T seconds after it's thrown off a cliff that's 80 feet in the air, an 80-foot cliff, okay, with an upward velocity of 22 feet per second is modeled by this formula h equals negative 16 t squared plus 22t plus 80. We want to find the height of the ball 2 seconds after it's thrown off. So let's get a little bit of a visual here of what's going on. Here's our 80-foot cliff. Here you are standing at the top of that, and you're going to throw a ball up in the air, and eventually gravity is going to kick in, and it's going to pull that ball all the way back down. And this formula here, height, is equal to negative 16t squared plus 22t plus 80, models the height of the ball after it's been launched up in the air with that 22 feet per second velocity off an 80-foot cliff. All right, so we want to round our answer here, our height, to the nearest tenth. We're simply going to evaluate this formula for the value of t equals 2 because we want to know how high is it after 2 seconds. So this becomes negative 16 times 2 squared plus 22 times 2 plus 80. All right, evaluating this using PEMDAS, we're going to first do our exponents. Negative 16 times 4 plus 22 times 4. We're going to simplify that, or sorry, 22 times 2. We're going to simplify that right now to get 44 plus 80. All right, negative 16 times 4 is negative 64 plus 44 plus 80. Adding left to right, I have negative 64 plus 44 gives me negative 20. Negative 20 plus that 80 gives me a total of 60. So the height of that ball to the nearest tenth, we'll go 60.0, is 60 feet in the air. So it must already be starting to come back down because we know that the ball started off at 80 feet above the ground, and now it's already starting to come back down, and it's about 20 feet below the top of that cliff. All right, guys, one last little word here about action problems. Your action problems follow on your notes now. Please take some time to go through those action problems showing all of your work in your math notebook, and we'll see you tomorrow in class.